so what we provided basically are like, you know, four things. We have a PNP, a plug-and-play quote daemon, which responds to remote attestation requests with a signed quote from the TPM. And so this is all happening at the application level, utilizing some of those services we talked about with TPM tools and things like that. We have a PNP trust verifier that verifies this quote. You know, we have the firewall exception service, which basically opens up a port on a firewall to establish that secure communications channel. And we have the secure communications channel using the secure socket layer and utilizing the TPM, you know, and its protected keys. So now we're not allowing the keys to be openly stored on the host. Okay. So when we look at this particular this figure, and it's probably, I apologize because I know the words are not, you know, large enough. So this is how we see this interaction, you know, occurring. So you have your plug and play embedded services user, and you have the provider. So the provider is actually going to evaluate, you know, the remote user or the remote entity. Think of this as an ATM. So the ATM here requests and embedded services on a particular port. So this is a well-known port that's available. And so the firewall exception service, so that port is not available. You know, it's closed. And so the firewall exception service on the server is going to say, okay, well, tell me what you're running. Okay, what is your state? You know, basically give me a quote. The TPM then has to construct this quote based on the measurements that are stored in its platform configuration registers. So then that's where the PNP quote daemon comes into play. And the TPM, the host says, TPM, give me a quote. Quote gives it to the host passes it on back, you know, to the server. So the quote info and basically a nonce for freshness. So embedded in the quote is a nonce because we want to know that this is actually a fresh quote. And so the PNP trust verifier will then validate. So what you have on your server end is the expected hash sequence for this remote entity. So you're storing that, and this is already embedded, you know, in your read-only image. And so you have that a priori stored there. So once it verifies, you know, that quote, then what you get is access granted or access denied message that goes back. And if access is granted because the quote was verified, you get this, you know, your trusted communication can be established at that point. And we're using the OpenSSL, you know, to establish that. And so that's really how the service works. Now, to actually set this up, you know, all the details are actually, you know, provided in the paper that we have under submission right now, and we'll make a available one, you know, via our technical report service, so you can see exactly, you know, how things are set up. But, you know, available on the website, it's my website. It'll be, if you go to www.cs.indiana.edu /RALHIL/PNP Trust, and that was in the, I think, the announcement that they put out, you can actually, you know, create a thumb drive with everything on there now. So we have everything. You can download it. There are instructions on how to actually set this up, and you can, you know, just create the thumb drive and boot your whatever, your laptop, your desktop or whatever, using this particular system. So it's using, you know, a Linux, you know, based operating system, and all of the services are actually available there. So let's see, I think I only have about, you know, 6 minutes. So, you know, I'll talk about, you know, what we want to do for future work. And, you know, if you have any questions, and, you know, some of the, you know, talk about some of the major challenges, you know, that we had. So with regards to the contributions, part of this, I mean, part of this process, it was a big engineering, you know, process. Really, I mean, that took about a semester just to get everything integrated, you know, just to figure out what the problems were, why we couldn't talk to the TPM, you know, which drivers actually did what, you know, collecting tools from multiple sources, you know, having the right OS that supported those tools. So, you know, getting the right BIOS that, you know, that had the communications to the TPM embedded. So a lot of this was an integration problem, you know. And so once we got over that task, you know, then it was, you know, now that we have the system in place, what are the services that we needed, additional service that we needed in order to facilitate this communication and allow us to verify the integrity of the remote system. Okay, but the biggest part of it was integration. Part of it was even finding the right OS such that the image wasn't so large that it didn't take forever to actually do the measurement, you know. So that took a bit of time too. So there were a lot of challenges. And so now, you guys, if you want to use this, you don't have to suffer, you know, that way, because we just have a step-by-step process for you just downloading, you know, everything that we have and just creating this thumb drive. And so we developed a platform for trusted computing research that integrates existing device drivers and new application level of remote attestation, integrity verification, and trusted communication services, you know, including the firewall service. And one future goal is to reduce the size of the file system image to support services for embedded devices that have limited storage. So we're doing all of this on, right now we're doing it on desktops and things like that, but you know, for smaller devices we would need a smaller image, and we're looking at some Debian Linux in order to do that. And another goal is to, where the real research comes into play, is evaluating the trustworthiness of a system. You know, how can we do this? Can we, you know, can we define some specific attributes that will allow us to map this large code base into a smaller space and do measurements on those particular attributes? I mean, that's where the, you know, the interesting research lies in this area. It's like, I have this predefined state, but can I say anything about the trustworthiness? And how do I measure, you know, trustworthiness of this predefined state? Now, when you're looking at entities or infrastructure components that are controlled by one particular entity or a part of an autonomous system, this is not a specific problem, because maybe they have in-house certification, they've already evaluated the software, they know exactly what the issues are. But if you are an entity that's trying to determine whether you're going to let this remote party host your, you know, your data, your applications, you know, how are you going to determine whether they're in a trustworthy state or not? You need some way of doing that. They can tell you, well, I'm running this certified code, but do you trust the software stack? You know, are there vulnerabilities? You know, how often has this particular software stack or elements of the software stack been compromised? You know, so that's where the interesting, you know, work lies here. You know, what we did was put together the platform so that we can readily begin to investigate, you know, the more interesting problems. So I think I have about 1 minute and 10 seconds. And so if there are any questions about, you know, any of this, you know, I would definitely.
Is it possible for the host to make what it sends to the TPM in some way? So maybe the TPM is looking for a configuration file and needs to make a hash of it and sends it off to the server for verification. Can the host, I mean, the host has control over that configuration file, so it can pretty much send maybe a valid configuration.
And so that goes back to the question before. How do you, you know, when you're initially booting the system, how do you verify the integrity of what's actually being loaded? Okay, so let's say, for an example, that you're not at each step verifying the integrity of the layer that you're loading. Okay, so you're not evaluating that. So the you know, the grub loader is not evaluating the OS, and the OS that you load is compromised. Then everything, your security is gone out the window at that point. So if you know, you have specific policies, you know, about, you know, that state about the you know, what that software should be at that layer, you can do the enforcement